So for the free undamped equation, remember I talked about in the tutorial, when you've got initial conditions, what you need to do is you need to apply the displacement when time is 0, and you need to find the derivative of the equation with respect to time, to find x dot, and then if you know the velocity when time equals 0, you can use that equation as well. And that will allow you to find A and any phase, phi or alpha, depending on which equation you're using. So here we've got the undamped case, so that up here, the first equation you see is that's the solution, the general solution, where we know neither A nor phi. But if you apply the initial condition at time equals 0, okay, which I'm going to call x subscript 0 over here, you can see quite clearly that what you end up with is a cosine. That term is 0, so you end up with a cosine phi. Okay. And here, if you take the derivative of this equation, obviously you get an omega naught that comes out, and the cosine turns into a minus sign. So that you end up with minus a omega naught sine of omega naught t plus phi. Plug in 0 for t in here, you end up with minus a omega naught sine of phi over here. So that's x dot subscript 0. And we also know that the solution is a1 cosine omega naught t plus a2 sine omega naught t. That's what we just covered. And if you remember, a1 is a cosine of phi. Well, that's quite clearly x naught. So there's your initial displacement, okay, at time equals 0 is a1. And a2 we know is minus a sine of phi. Well, here we've got a minus a sine of phi. If we divide that by omega naught, then that's your x. Then that's your a1, a2, and obviously there's our initial condition in terms of velocity. So if you've been given a question that's a free, undamped system, and you've been given initial conditions, what happens when x is 0 and what happens when x dot is 0, sorry, when time is 0 for the displacement x naught and the displacement x dot naught, then you can go straight to that solution, this one here, okay? Knowing that x naught is a1 and a2 is x dot naught divided by omega naught. And so there's the solution in terms of initial conditions. So like I said, if you know your system is undamped and it's free oscillating and you've been given x naught and x dot naught, you can go straight to the solution, which is on your equation sheet, you'll see, and you have your solution. You don't need to worry about having to make the derivative. Now we can do a similar thing with the damped response. If you remember, the top equation up there was our damped response. So it's very similar to the the undamped response, except we have the decaying exponential in here. Okay? And if you plug in 0 for t, then obviously e to the power of 0 is 1, so that disappears. This term drops to 0, and so you end up with a cosine of alpha, which is equal to x subscript naught. Okay? Now, this is where it gets a bit more complicated. X dot of t, if you take the derivative of this equation, okay, you have to use both the product rule, because you've got two functions of time in here, this one and this one. Okay? So you have to use the product rule. And you have to use the chain rule with both of those terms as well. Okay, so when you take the derivative of e to the minus zeta omega naught t, you end up with e to the minus zeta omega naught t times by minus zeta omega naught. Okay? And obviously when you take the derivative of cosine of omega dt, you end up with minus omega dt times by sine of omega dt. Okay? Now because you've got the product rule in here, that's why you've got both of those terms in here. Okay? If the screen was working with the pen, I would explain it in more detail, but it's quite, obviously it's not. But if you came to the tutorial, I would have covered it as well. So if you plug in 0 for the derivative, for the velocity, okay, you end up getting, obviously this term drops to 1. You retain a, you get minus zeta omega naught times by cosine of alpha. Now cosine of alpha quite clearly is x naught, okay? A cosine of alpha is x naught. So you know what those two terms are. And you get minus omega d sine of alpha. Okay? Now we know that x naught is a cosine of alpha. We can rewrite the velocity equation at t equals 0 as this. Okay? And it's quite clear that you can rearrange to find minus a sine of alpha, okay, as this term. So there's our a1, for that alternative form. And there's our A2. And so you can take that term and plug them into the alternative form that we had. So there's the alternative form. We know A1 and A2, and so you can plug them in and you end up with this equation here. Again, this is on your equation sheet. So if you've got a free damp system, you end up with, you can jump straight to it, because if you know the initial conditions, here and here, okay, you can work out what zeta is, and omega naught and omega d, you can just plug the numbers in and you get the same solution